those are some of the formulas, I guess we could say. And if you wanted centripetal force, right? If I wanted Fc, you just put a m in front of them, right? M 4 pi squared r all over t squared. But I want to show you a neat little trick that the textbook does. They don't do a great job of explaining it. I think I do a much better job. You know, I'm sure you'll agree. Are you with me, Hannah?
Yep.
You know, I don't even know. It's 6.4 in the book. I don't know the page number. 6.4 in the book. But I do want to remind you that period is 1 over f, right? Which means, conversely, that frequency is 1 over the period. 215? Okay. Write this wherever you want. I gave you that sample page. Write this on the back of the sample of the thing that I wrote, right? So those are the formulas at the top there that we've got so far. And we've got t equals 1 over f and f is equal to 1 over t. Now, you might see that 2 pi r, that's an r, poor r, but it's an r, 2 pi r over t, that's over t. Can we do something with this over t here? Like if I take this and go in there, I'm going to end up with 2 pi r instead of being over t. Anyone? Times f. Okay, so all that does is it eliminates the need to sort of do that one step, do that flip. Like instead of having to take t, instead of having to take the frequency and going 1 divided by the frequency to get the t and then putting it into there, you can just use that formula sort of as a whole, right? Does that kind of make sense? I mean, you don't have to do it. I'm just saying it because the textbook does that. And if you're looking at the textbook and you're wondering, okay, where are these coming from? I'd like to know. Carter, what are you doing, man? I've started. What Dan just said. Okay, so can I do the same thing over here? With 4 pi squared r over t squared, can I take this and plug it into there? And the answer is yes. I'm going to get 4 pi squared r f is equal to 1 over t. This is t squared. F squared. 4 pi squared r f squared. That is a lot of squaring. Yeah? It's up to you. I'm just showing you it's an option. And of course, now, if you want to turn that into centripetal force, you just put a m in front of it. So, m 4 pi squared r f squared. Yeah. It's an option. That's all I'm saying. No magic triangle there, though, right? Okay. Yeah. Okay, so here's example number 7 that's on the front side of the paper. Okay. Strange question. A 0.2 gram flea sits at a distance of 5 centimeters from the center of a rotating LP record. Anybody know what the LP stands for? It's not Louisiana Pacific. Long play record. Because they used to have the 45s, which were like the little tiny ones, one single song, and then the LPs were like a full album. You got 5 songs. Yeah, and then you had to flip it over. Yeah? For me? Then you got another 5, or if you're lucky, maybe 6. Unless it was like Rush or something like that. Then the whole side would be just one big long song. Yeah. Yeah. Then there's the double albums where you get 2 albums. You get 4 sides. Alrighty. So this record is rotating at 77 RPM. So these are old granny style records, okay? The regular ones from the 70s and the 80s that your parents had, or might still have, are 33 1/3 revolutions per minute. The big giant ones that Granny has from the 1940s are 77s. Yeah, that is fast. What centripetal force must be provided by friction to cause the flea to maintain its UCM? Okay, so I've got, and it's kind of hard to draw a picture here. Here's the record. There's the center of it. Right? And here's this little tiny flea. And this radius is 5 centimeters or 0.05 meters, right? So as it's going around, the flea is trying to sort of like fall off, right, due to inertia. So what provides the centripetal force? Friction, right? Fc is the friction force. It's kind of like, you might recall a question from grade 11. There was a commuter standing on a train, and what friction force was there to hold them in place as they move on the train? Similar to that question. Okay? So how are we going to get at, this is sort of like a big giant, almost a review of a lot of things here. How are we going to get the FF, do you think? Well, there's mu, right? Mu equals FF over Fn. Do I have a frictional coefficient here? No. I do not, right? Anna, you need to put it away. Pay attention. Seriously. Well, let's have a look here and see what we do know. We know the mass, right? We know the radius. We have the 77 RPM. What is that? Revolutions per minute. Right? We need the period, or we need the frequency, right? So what does 77 RPM mean? 77 RPM is 77 revolutions in 60 seconds. Now, do you care if we have to get the frequency or the period?
Frequency first.
Okay. The frequency then is how many revolutions in? 1 second. So cross, multiply, put a 1 there, right? And you're going to get 60x is equal to 77. Oh, you know what? It's just 77 divided by 60, isn't it?
1.28.
Yes. 1.28. And the unit, do you remember?
Time?
Hertz. Yeah, hertz. 1.28 hertz. 1.28 revolutions per second. So a little more than once around every second. That is our, I guess, instead of x there, maybe I should say F. Okay. Okay, so can I figure that, if I've got, let's just go back to these formulas that I just wrote here. Fc, do I have the m? I have the mass. 4 pi squared, do I have the radius? I do. I think we can do that one, can't we? Fc is equal to m 4 pi squared r f squared. Now, the only thing we have to be cautious about, this is 0.2 grams. Does that sort of feel like we should do something there? Yeah, so now 0.2 grams in kilograms. Divide by 1,000, so yes, that's 0.0002 kilograms, right? Do we need it by 9.8? No, this is mass. Okay, so big long line of numbers here. 0.0002 times 4 pi squared. I'll leave that in brackets. The radius is 5 centimeters. Does that have to be in meters? Uh-huh. There you go. Now, is this going to be a big number or a small number? It's just a little tiny flea. Doesn't take much friction. Oh, yes. And that is a common mistake, and I just made it. How many zeros? 3? I have 6.5. Okay. With that many zeros, you should probably go one more number, I think. Or if you want to write that as 6.5 times 10 to the minus 4. Minus 4 newtons. Okay? Yeah. You can change your calculator to, yeah. Now, how much room do you guys have there still? Quite a bit? Okay, because I'd like to, as I'm looking at this, I'd like to extend this question a bit. Because I talked about that mu value, right? What does the minimum mu value have to be for this to happen? Well, mu equals FF over Fn, right? So the FF is which number? The friction force has to be the centripetal force, so this is going to be this 0.00065, and Fn is going to be mass times gravity, right? So 0.000, put an mg there for completeness, 0.0002 times 9.8, and you should put that in big brackets down.
Lockdown.
You guys get a number here? Oh yeah. I don't know if they have lockdowns in university stuff. Yeah. You do have to be careful here because it's the double bracket, right? So make sure that something like this happens. So this would be 0.00065. Oh, come on. 0.00065 divide by, and then go bracket 0.0002 times 9.8, and I get 0.33. 0.33, and that would be the minimum value, right? If it was anything less than that, what would happen? The fleet would fall off, right? If it was anything less than that. So that's actually fairly high, right? Like it has to be higher than that. And I just realized, while you guys are sort of jotting some stuff down there, I read ahead there to example number 8 because I'm kind of doing these in a little bit of a different order this year. And I realized that I shouldn't really do number 8 yet because it's a vertical circle. So I will leave out number 8 for today. The 250 gram chestnut. I will do vertical circles tomorrow, which is a little bit of a challenge. And then we got to get into the banked on bacteria. And we'll easily be done by Wednesday. Oh, we got to do flying pig lab too. Yeah. Let's aim for Thursday. Test Thursday.
This Thursday?
No, next
I thought
Thursday.
you said that we wouldn't do a test in this year, it would just be on the exam.
Thursday
You did
is
say
the
that.
exam. Convention.
Oh, yes, right.
That's this Thursday?
Yeah, so maybe we should just aim for Friday, and that way, regardless of when your math exam is, we don't have, right? We'll just sort of review, and write the test back. If you want to write it a bit day early, whatever. Sounds good to me.
Don't you still get to do one afterwards, right?
Yeah. Yeah. Yeah, that would be the Thursday after. Well, we'll wait and see how things are going next week, and yeah. I'm not too worried. We're going to easily finish. Yeah, you guys can work.